Good afternoon to you viewers and subscribers. Welcome back to my channel. Welcome back to another video. So in this video, I have I have managed to make a trip down to the Maypen leg of the Southern Coastal Highway. I'm not sure if this is a part of Highway 2000, but this project is a project that spans from the eastern section of the island all the way to the western section of the island. So the road runs from an east to west direction and a west to east direction to and fro. So this highway is going to be a four-lane highway, two lane of traffic, two lane of traffic on the carriageway is going west, and two ways of traffic going east along that highway. So I have managed to show you a little synopsis of what is going on the bridge deck. I have observed they're putting in the matting or the reinforcement for the deck. I have make a trip down beneath the bridge and show you the different parts of the bridge, and as well I've shown you a section of the road pavement that is already paved. So as usual, I am asking you to watch the video until the end. If you're a new time viewer of this channel, please to hit the subscription button and hit the like button. When you watch the videos until the end and you hit the like button, it gives the video more prominence and more viewers will be allowed to watch the videos. So as usual, take care and watch the video until the end. Thank you.
Good morning to you viewers and subscribers. So I'm here at the Maypen leg of the Southern Coastal Highway, and based on my information, um, this this highway is going all the way to Montego Bay, traveling along the southern coast of the island. So what you're looking at now is the reinforcement for the bridge deck. So they are putting in the reinforcement for the bridge deck here, and this half I think is the half that they're working on the bridge deck is going towards Montego Bay on the left here. So this is a reinforcement. So what you have here on the right side there, that's the barrier, or they're gonna put a moment slab right here. I think those holes there you're looking at is for the drainage, I think, or for the lighting that is going on the bridge. I'm not sure. I've not looked at the plan. So they are putting in the reinforcement for the deck here, and I think there's going to be a double mat deck, and this is the reinforcement for the center median. This center median right here, center median. So this is going to divide the road structure into two halves, and I think what we're looking at here now is the diaphragm of the bridge. They're going to put up some diaphragm right here in this slot here. So all these hooks here on the bridge here, these are going to allow the concrete and the deck to become composite and behave as one unit. So I'm not allowed to go on the deck to show you more because I do not have my protective clothing. I did not have my PPE, and in order to go on the bridge, you have to have your helmets, your safety, your vest, your safety vest, and your safety boots. So I'm going to take a look now to what beneath the bridge looks like. So I'm going to show you what beneath the bridge looks like. So we have, again, that's the barrier there over there. They're going to put a moment slab there. So they're going to put in a double mat now for the deck, and that's the center median reinforcement. So I'm going to show you now what the beneath the bridge structure looks like. So what you're looking at now is beneath the bridge. So this is the beneath the bridge structure. So what you're looking at now is the beam, and this beam is called a pre-stress bulb T-beam. So this is, I think it's 5 span. This bridge is 5 span. So let me count them: 1, 2, 3, 4, 5. So it's a 5 span bridge with 1, 2, 3, 4 center median, which is called piers. So what you're looking at now here is the pier column, that big round concrete structure you're looking at there, and you can see the pad footing or the spread footing, which is used to spread the load of the beam. And on top of the piers, on top of the columns, is what you call the pier or the pier cap, and it is cantilever. This is known as a cantilever pier cap, and it is I don't think it's pre-stressed though, but these beams for sure are bulb T-beam, and they are pre-stressed. So looking at the bridge here, these holes in the bridge, they are known as coppers, and they're going to be used for the drainage of the bridge, for the water to drain off the bridge. So they temporarily put plywood over it so that nothing can fall through and it doesn't create a hazard for the workers on the bridge. So what we are looking at is abutment 1. So we have abutment 1, we have pier 1, pier 2, and pier 3, pier 4, and abutment 2. So it is 5 spans, 5 or 6 span, and we have abutment 1, pier 1, pier 2, pier 3, pier 4, and abutment 2 all the way to the opposite end. So as you can see here, the part of the bridge deck is cantilevered. I think this looked like about 3 feet. So it's 3 feet cantilevered. So let me show you the structure on the bridge now. So what you're looking at here now, this is abutment. This is known as the beam seat. So this beam doesn't carry any bearing. So this is known as the beam seat, or what is called a plinth, right? So there are a lot of this bulb, pre-stressed bulb T-beam, right, which is beneath the bridge, right. And if you notice too, the beams are tied to each other to limit the lateral movement of the bridge due to wind and seismic action. So I've worked on a lot of these back in the States. I worked on a lot of these bridges back in the States. Right. So I think this monument here is known as the diaphragm. They're going to pour the diaphragm at the abutment, right? Yeah. So I think this has to do with compression, the compression plates for the moving up and down of the bridge, especially when the vehicle enters the bridge and when the vehicle is exiting the bridge. That's sudden movement. So one thing I didn't observe about this bridge, I didn't observe a approach slab. So most of the bridges that we design, we put an approach slab on the bridge. And the approach slab serves as a transition point, a transition of the load, the vehicle load, transitioning onto the bridge deck. So when the vehicle is driving, it don't hit the deck sudden. It hit the approach slab, and the approach slab transfer the load to the bridge deck. So that is dependent on the traffic count, if the bridge is going to be heavily utilized, by a lot of vehicles. So it depends on the amount of traffic. So if the traffic is a certain amount, the bridge has to be designed with an approach slab. If not, you don't need an approach slab. If the traffic count is below a certain number. But once the traffic count is above a certain number, the bridge has to have a approach slab at wherever the traffic is going to hit the bridge. So it does hit the approach slab and transition onto the bridge. It doesn't hit the bridge deck with that sudden load. So it's looked nice so far. It looked nice so far. So what we are looking at now is the existing bridge for the Maypen bypass. So that is it. We are seeing over to the left there. Can't go down any further. Right. So I did mention to you about those holes in the deck, in the cantilever deck, and they are called scuppers, and they are there for drainage purposes, to drain the water off the bridge. So it looked like to me this bridge is super elevated to one side. All right. Yes, as I was saying to you, beneath the bridge, I have not observed any approach slab. Oh yeah, probably, yeah. So yes, there's an approach slab. So this is it. Yeah, so this is the approach slab here. So this is the approach slab here. Right, and it's supposed, right, so there's supposed to be one over on the other side. So this is the approach slab, folks. As you can see, it stops right here before it gets onto the bridge. Right, so this is the approach slab, as I was mentioning to you, beneath the bridge. So, and there is supposed to be one on the other side for the traffic coming from the opposite direction. So as I said to you before, the approach slab serves as a transition point that the vehicular traffic doesn't hit the bridge deck suddenly. So it transfers the load onto the bridge deck and allow the vehicle to transition its load across the bridge without that sudden impact of load on the bridge deck itself. So that is one of the approach slab, and then there's supposed to be one in the other direction. So that means on the right, as I said to you before, that lane on the right is taking you back into Kingston, wherever the highway is going, and this side on the left is taking you into Kingston, wherever the highway is going, back to the east, and the right lane here is taking you to Mandeville or Montego Bay, to that side. So the approach slab is on the opposite side for vehicle coming in that direction. So that's the information that I was looking for. Yeah, and I think this little wall here, yeah. No, this bridge doesn't carry a cheek wall, and the cheek wall is supposed to be at the side of the abutment. So, yeah. So I'm here to show you the pavement section. So I was told that several hundred meters of this road is already paved. I think the wearing course, or probably the binder course, is already on the surface, some distance along, and they are now just waiting to put on the rearing course of the asphaltic concrete. So this is the road section here. So we have two lanes in either direction going in the opposite way. So I think this lane here to the left is going towards Mandeville onto Montego Bay when the road is completed, and the lanes to the right here is going into Kingston. So what you're looking at here immediately in front of us is the center median. This is the center median right here, center median, and that serves as a divider for the highway. So I guess in the middle here, this slot here, they're going to put the electrical insulation here. I don't know if they're going to have any traffic signals on this pavement here, or they're going to have lighting. And what I've noticed, most of the highway here, especially Highway 2000, there are no lighting on the road. I think they should put lighting on the road and make traveling at night much more easier. You know what I mean? Because some vehicles, they do not have proper lighting, especially at the back, and you know what I mean, when the time is dark, you can easily run into the back of a vehicle on the highway because there's not enough lighting on the road structure. So I'm just walking and showing you this now. So I think the first layer is on. And what they call the first layer here is the binder course. So, and then to the right of the binder course here, this is the shoulder that you can pull off. I think the minimum width of a shoulder is 8 feet, 6 to 8 feet. We use 8 feet in the States. And I think there's a shoulder to the left as well. I have not seen the drawing, so based on my experience, I'm only telling you what I forecast is going on. So this is supposed to be a shoulder too, but I know definitely on the right here is a shoulder that you can pull off the road in case of any emergency. So yeah, so this is a general thing here. Right. So this is a southern coastal highway. I wish I had a drone that I could give you more footage, a longer footage, a more extended footage of what is going on here. So I'm presently walking, as you can see, so I don't know how far I can go. Yes, so as I said to you before, I like these projects. I used to work with the National Works Agency. I started out with the Ministry of Local Government and Works in 1992, and I worked from 1992 up until 1998 as a junior works overseer. Then I left, joined the Jamaica Fire Brigade, worked for 10 years, and then after that I studied to become an engineer, and then moved back to the National Works Agency in 2008. I think I worked there for 4 years before I migrated as a clerks of works, as a site engineer. So basically this is it here, right? That's it here. So I think over there looks to me like they set up their concrete plant. I can see material loaded into the truck. I can't say for sure, but it looks like they set up a little concrete plant over there. I'm not certain. That's my speculation. Or I don't know what plant that is. Don't think I'm going down there. And then over on this side here, they are doing another road. I think I was told that they're setting up this road pavement here for the exit to go to the range. I was told that there's a range somewhere over there, and this road is going to take you there as well as take you out. So as you can see, that's the vibrating roller there, rolling what is now, this is now known as the subgrade. So a road have several different layer system. We have the subgrade, which form the foundation for the road structure or serve as a drainage for the structure. Then you have the base, then you have the sub base, and then you have on top of the sub base you have the wearing course, and then on top of the wearing course then you have the wearing surface. That is where you put your asphaltic concrete or your double surface dress. So there's a subgrade, the sub base, the base course, and the wearing course. So all the loads on top of those course, they are there to resist against cyclic loading, and the load is then transmitted to the subgrade, which acts as a foundation for the pavement. So I'm going to be doing some videos like that to show you how a road is designed. So when you have time and you can sit down and put those videos together. So yeah, all right. So I have come to the end of this video. So as usual, you know what to do already if you're a follower of this channel. If you're new, just hit the subscription button, watch the video until the end. Thank you.